Hi, I'm Cédric Androuët from the Canadian Nuclear Safety Commission, and I'm here today to talk about trending integrated leakage rate test results, which we call ILRT results for the rest of the presentation. I'd like to thank and acknowledge the contribution of my co-authors, George Stoyanov and Nitheanandan. The presentation will be divided in 4 sections. After a brief introduction, some typical pressure test results will be presented. Various methods used to trend and extrapolate these test results will be introduced, and a brief conclusion and a few recommendations will close the presentation. Concrete containment structures of existing Canadian nuclear power plants are aging, with all active reactors being in operation for over 35 years. These structures are part of the 4th level of the Canadian Defence in-depth framework, making them the last barrier between radiation material and the public and the environment. To ensure their leak tightness, these structures shall be leakage rate tested, in accordance with ILRT requirements as detailed in CSA N27.7-17. The structure shall be tested either every 6 years or following a performance-based interval, as detailed in the informative Annex E and as agreed upon with the AEHA, which is the CNSC in Canada. To do so, the prerequisites mentioned in clause E.2 shall be met, and there shall not be any significant adverse findings or trends. Amongst the prerequisites to establish a performance-based ILRT interval option, demonstration shall be made to the AEHA that the leakage rate trends are stable over at least the 2 most recent post-commissioning outage tests. Stable is defined in CSA N27.7-17 as no statistically significant increase that would cause the acceptance leakage limit to be exceeded if it changed in a linear fashion over the next test interval. This definition may be debatable and subject to interpretation, which is what I'm going to discuss in this presentation. To assess the impact of various options for trending ILRT results on the extrapolated results, and therefore on the performance-based ILRT interval, some hypothetically assumed ILRT results of a concrete containment structure potentially observable in a Canadian NPP are considered. Please note that the absolute values presented should not be regarded as being important, as the key message delivered in this presentation is more about the impact of the various trending strategies than about absolute values of the ILRT results themselves. So the assumed NPP structure is a 40-year-old concrete containment. It has been pressure tested at its positive design pressure every 6 years since commissioning, and it underwent major repairs between the full design pressure tests carried out at 24 and 30 years of age. For illustration purposes, an hypothetical typical leak rate limit of 1% volume power would be assumed. So these are the assumed ILRT results that would be used throughout the presentation. First of all, it is worth reminding that the purpose of a trend analysis is to quantify and explain trends and patterns showing up in a noisy pattern over time and to determine to what extent 2 or more numerical variables are correlated. Various tools may be used to identify trends, one of the most popular being curve fitting and smoothing. One important aspect to consider before correlating data is obtaining a sufficient sample size to ensure that the derived correlation can reach a desirable correlation coefficient and confidence. Various different types of trends may be considered. To identify the best curve fit, the coefficient of determination, R-square, is generally used to quantify the extent to which the data are replicated by the model. So let's start with the simplest trend, which is the linear trend over the whole set of data. It can be noticed on the figure that the proposed fitted curve does not represent the input data very well, with a low coefficient of determination of 0.45. The linear trend proposed by this simplistic approach considers the whole set of data, regardless of the specific condition of the structure when the tests were performed. This is incorrect. When trending a series of data, particular attention must be paid to whether the series of data can be compared to one another. That is, whether the leakage rates have been obtained for comparable condition of the structure. In this example, major repairs were completed between the pressure tests carried out at 24 and 30 years of age, which resulted in a decrease of ILRT results, as can be seen in the figure between this point and this point. This has drastically modified the trend of leakage rates, and as such, ILRT results obtained before and after the major repairs shall not be considered altogether when trending leakage rates. Let's see now one of the ways in which the CSA N287.7-17 requirements may be interpreted. Clause E.2.1.2 stipulates that the trend shall be stable over at least the two most recent post-commissioning outage tests. So let's consider the two most recent data points and apply the CSA requirements with regards to the linear fashion change over the next test interval. At first, this might seem to be a perfect correlation with an R-square of 1. However, and this is what I mentioned earlier, an R-square of 1 may not always reflect an adequate correlation. Actually, it reflects here a lack of data points. This was expected as only 2 input data points were considered in the analysis. And a trend defined over 2 data points is not a trend, but nothing else than a straight line connecting these 2 points. In this case, the analyst's judgment is crucial, as the input data points are not statistically sufficient to allow for any trending of the specific results. As such, the CSA requirement mentioning over at least the 2 most recent post-commissioning outage tests shall be considered with extra care. The next type of trend presented addresses the issue that we talked about earlier in terms of data that can be compared to one another. This time, the trend of ILRT results versus time is characterized based on the more statistically representative data points, and the trend is applied afterwards to the few results obtained after the major repairs as a characteristic trend of the leakage rate of the structure. When we inspect the proposed curve fit, one may see that the correlation between the input data and the proposed equation is much better, with a reasonably high R-square of 0.93. So this is a much better curve fit. However, some more sophisticated trending strategies may be used to improve the validity and accuracy of the trends identified. Another type of regression analysis which may improve the reliability of the trend identified is a polynomial trend. Indeed, a regression analysis based on curve fitting requires not only searching for the best coefficient of determination, R-square, but also identifying the shape of the curve that may best fit the data. So, following the observation of the data points, it appears that a polynomial trend may fit the data points best than any other type of trend. The proposed curve actually fits almost perfectly with the input data, with an R-square very close to 1. So in this case, the model provides an adequate fit to the data, and as such, it may be considered characteristic of the trend of the leakage behavior of the concrete containment structure. Lastly, another way in which the CSA N287.7-17 requirements may be interpreted is presented. As a reminder, clause E.2.1.2 stipulates that the trend shall be stable over at least the 2 most recent post-commissioning outage tests, and stable being defined as no statistically significant increase that would cause the acceptance leakage limit to be exceeded if it changed in a linear fashion over the next test interval. So there is no requirement for the trend obtained through the regression analysis to be linear. CSA rather indicates that the extrapolation of the expected test results may be performed in a linear fashion based on the trend identified through the regression analysis. With this interpretation of the requirements, the extrapolation performed in a linear fashion may therefore be referred to as an asymptotic trend. This interpretation is combined with the principle of only considering the more representative set of data to establish a trend as introduced earlier. The proposed extrapolation performed in a linear fashion is used to predict the future ILRT results. So again, the trend identified through the regression analysis is not linear. However, the extrapolation of the trend is linear, which is in line with the definition of stable given by CSA. So if we take a closer look at the different extrapolated ILRT results, we may observe some major differences in the conclusions that might be drawn. Here is a recap, and the figure from the left is zoomed on the right, and this is the figure we will use for the discussion. So various types of regression analysis have been assessed, and depending on the type of curve fit selected, the conclusions drawn may be very different. The R-square obtained for the different trends are varying from 0.445 for the simplest linear trend to 0.997 for the polynomial trend that is the best curve fit identified through the input data points. This is a very important observation, as the quality of the extrapolation performed based on the regression analysis gets highly impacted. It is reminded that the unit R-square obtained here is based on 2 data points. And this may not be associated with a perfect correlation because only 2 input data points may not be sufficient to establish a trend. And again, depending on the regression analysis considered, the extrapolated results would be very different. The figure speaks by itself. As an example, a difference of more than 30 years was observed for the exceedance of the leak rate limit. This is very significant. In conclusion, ILRTs are performed to assess the leak tightness of Canadian NPPs either every 6 years or conforming to a performance-based test interval, which may be established if it has been demonstrated that the leakage rate trends are stable over at least the 2 most recent post-commissioning outage tests. So following the various analyses presented, the following conclusions can be drawn. First, the regression analysis shall be data-driven, and the analysis should focus on identifying a trend that may be considered as being characteristic of the input data. A particular attention has to be paid to whether the data considered in the regression analysis may be compared to one another. Data obtained in comparable conditions has to be the only data considered in the process of identification of a trend. Trending ILRT results in a linear fashion may lead to very significantly different extrapolated ILRT results, depending on how the linear fashion requirement is interpreted. In particular, linear fashion as expressed in CSA N287.7-17 does not necessarily mean that the trend obtained through the regression analysis shall be linear, but rather indicates that the extrapolation of the possible expected test results may be performed in a linear fashion based on the trend identified through the regression analysis of previous ILRT results. In this example, a multi-step data-driven regression analysis has shown that the curve fit that ended up being the most representative of the past ILRT results was not a linear trend, but a polynomial one. So the conclusions drawn based on the extrapolated data may be very different depending on the regression analysis performed. When compared to the linear trend over the whole set of data, extrapolating the ILRT results based on the polynomial trend led to an increase of the extrapolated ILRT result of up to 55% over the 2 next test intervals. And it also decreased the time remaining before reaching the leak rate limit of 31 years, which is very significant. It has been demonstrated in this presentation that regression analysis by curve fitting to identify possible trends in a set of data may require more analysis than expected at first while reading through the CSA requirements. Extrapolated ILRT results assumed from regression analysis may be used as a justification for establishing a performance-based interval. This paper has shown that different trending approaches may draw very significantly different conclusions, some of which leading to extrapolated test results that would not meet the acceptance criteria. So a performance-based ILRT approach should include a thorough regression analysis of past ILRT results to identify possible trends for extrapolation purposes. I thank you very much for your attention, and I would be pleased to answer any question you may have.